Have you ever used ChatGPT or Google Translate? I mean, even just a simple Google search. If you have, you've been using this incredibly powerful AI architecture, probably without even knowing it. It's the engine that's really running under the hood of this whole modern AI boom, but most people have never even heard of it. So today, we're going to pull back the curtain on the transformer.
Okay, so let's start with the most basic question of all, right? How does a machine actually get the meaning of what we're saying? For us, it's easy. If I say, the robot picked up the ball because it was heavy, you instantly know that it refers to the ball. But for a computer, that is a huge, huge challenge. And to understand how they finally cracked it, we first have to look at the big problem the transformer was built to solve.
So before 2017, the world of AI language models looked very different. It was dominated by things called recurrent neural networks, or RNNs for short. And look, they were clever for their time, but they had this one huge Achilles heel. They processed everything sequentially, and that created a massive memory problem.
Yeah, this really shows you the problem perfectly. The old models had to read a sentence like this, one word at a time. Seriously, it would read the first word, try to remember what it meant, then move to the second, trying to remember the first, and so on and so on. But that's not how we read. We take in the whole sentence at once. Our eyes kind of jump around, connecting ideas to get the full picture almost instantly. The old way was just clunky and incredibly inefficient.
A great way to think about it is like trying to read a whole book through a tiny little straw. By the time you get to the end of a long, complex sentence, the context from the very beginning is super fuzzy, or it's just gone. The technical name for this, by the way, is the vanishing gradient problem. That crucial information from the start of the sentence just faded away, making it basically impossible for the model to understand the relationships in long pieces of text.
But then, 2017 happened, and everything changed. A team of researchers at Google came up with this totally revolutionary idea. They thought, what if you could just throw out that whole sequential, step-by-step process and replace it with something way more powerful?
And this was the title of their groundbreaking paper. Attention is all you need. I mean, what a bold claim, right? They were basically suggesting that the entire foundation of those older models, that step-by-step recurrence, wasn't even necessary. All you needed, they said, was a way for the model to focus on the most important parts of the sentence, all at the same time. And the magic behind this idea is a mechanism called self-attention. It's a fancy name, but it's basically a superpower. It lets the model look at an entire sentence at once, and for every single word, it calculates a connection score to every other word in the sentence. This score tells it how important each word is to the others. It's how the model finally learns that it, in our sentence, refers to ball, even though the word robot is closer. It can see the whole context. Okay, so we've got this incredible concept called attention, but how do you actually build a working machine out of it? Well, the original transformer architecture has two main parts that work together like a team. You've got an encoder and you've got a decoder. The easiest way to think about it is like this. The encoder is the reader. Its job is to read your entire prompt, your whole sentence, and use that self-attention magic to build a really deep mathematical understanding of what it all means. Then it hands that understanding over to the decoder, which is the writer. The decoder takes that rich context and then one word at a time generates the best possible output, whether that's a perfect translation or the next paragraph in a story you're writing. But here's where it gets even cooler. The transformer doesn't just have one self-attention mechanism looking at your sentence. No way. It uses several of them all at once, in parallel. It's called multi-head attention. And you can think of it like having a team of experts all reading the sentence at the same time. You've got one head that becomes an expert on grammar. Another one is amazing at figuring out who did what to whom. A third might be tracking the style or the tone. Then, the model combines all of these different perspectives to get this incredibly rich, complete picture of the language. So this wasn't just some clever idea stuck in an academic paper, not at all. This unique design unlocked a completely new level of performance and scale, and it directly lit the fuse for the AI explosion that we are all living through right now.
The impact was just immediate and exponential. Just a year after the paper dropped, you already had foundational models like BERT from Google, which is basically just the reader part, and GPT from OpenAI, which is just the writer. And these models, and all of their descendants, like the one everyone knows, ChatGPT, are all the direct children of that single breakthrough paper from 2017.
And this right here, this is the secret sauce. This is the key to why it took over so fast. By getting rid of that one word at a time approach, transformers can process all the words in a sentence at the same time.
This makes them perfect for the kind of parallel computing that modern computer chips like GPUs are amazing at. This slashed training times, which meant researchers could suddenly train models on way bigger datasets than ever before. And that scale is exactly where their incredible abilities come from.
But the revolution didn't stop with just text. You might think this is just a story about language models, but the core idea, using attention to figure out relationships, turned out to be unbelievably versatile.
Yeah, this is the part that's truly mind-blowing. People realize that a sequence doesn't have to be a sequence of words. What if it's a sequence of little patches from an image? Boom, you get vision transformers that can understand pictures. What about a sequence of audio snippets? You get state-of-the-art speech recognition, like OpenAI's Whisper. A sequence of amino acids? You get AlphaFold, which is literally solving the problem of protein folding. This one single idea is now dominating almost every corner of AI research.
So when you boil it all down, the Transformers' great gift to AI was context. The ability to understand not just individual pieces of data, but the whole intricate web of relationships between them. It's what took AI from a cool lab experiment to a technology that's truly changing the world. And it leaves all of us with the biggest question of all. Now that machines can truly understand context, what's the next great leap we need to teach them? Thanks for watching.